Here we go. I'm live with 52 weeks of Swift starting on error handling, and I'm going to get right into it and share my screen here. All right, so what we have is error handling here. So basically with error handling, the idea is that when there is this condition that's occurring, you're going to do something different to handle it. Let's say you're trying to open up a file and the file isn't there. What do? What are the different things that you can actually take care of? In the case of Swift here, we're able to propagate errors using throwing functions. And so what these do is they indicate that a function, method, or initializer can throw an error, and you write that throws keyword in the function declaration after the string. So let's go ahead and try that out. So if I go over here and I take this and paste it into our playgrounds, what do we get? I can see this, that in this particular scenario, we get an error. Let's go ahead and see what this, it's should be in the side of the body of a function, right? And so in this example, the vending machine class has a vend item method that throws the appropriate vending machine error if the requested item isn't available, is out of stock, or has a cost that exceeds the current deposited amount. So this looks like a pretty good example here to paste in and see if we can get it to run. So I'm going to throw down here, and we have a struct here which has pricing count. There's a class now that and actually it looks like I might need, let's make this a little bit bigger. Cannot find vending machine error in scope. Do we need that? No, I don't think we need that. Let's go ahead and try this out. So basically, yeah, we have a vending machine here with candy bars, and we have the mutable variable coins deposited. There's a function that has a guard here where it has the vending machine error, and there's also a guard here that is looking for out of stock. And if there are errors there, this will throw this out of stock error, and the rest of the code is just logic. So it looks like what we're missing is basically that error here, right? So we're missing this this vending machine error out of stock. And if I go down here, let's see if I can find that anywhere. So I don't see that inside of here. Oh, here we go. I'm missing, I didn't define it earlier. So basically, I'm going to put this on the top here, this vending machine error. Let's go ahead and do that. Go ahead and do this. Okay, so we have a enum here, vending machine error. And that solves why we were having issues throwing this. Now, if I go ahead and if I run this, everything is able to compile. And the only thing I need to do is basically try this thing out. So what I'm going to do is I'm going to create a new immutable variable called favorite snacks. This will be the person, and it'll be the whatever the snack is they like. And then I'll build a function that will handle that. And if we scroll through here, this goes through and it uses that vending machine class, and it's able to pass in the person. And in this particular example here, we have, I believe, an optional value for what the snack name is. And so that looks like that works as well. And then we can build another one, which is purchase snacks. Go ahead and do this next. And then in that particular scenario, we see basically Bob, Licorice, Alice. So let's see, that's here, Purchase snack. All right. So then, in a nutshell, what do we care about? Well, when we're building this structure, handling errors, there's a do catch, do something, try it, catch this pattern, catch the second pattern, catch this other pattern. So that's really the idea here, is that your errors are, or exceptions are, basically pattern matching problems. And in particular, now that we've got all this stuff, we can build out a big use case. And so the use case would be right here, vending machine use cases. There we go. So we've got a vending machine instance. We put 8 coins in. We try to buy the favorite snack, and that should be a success. But we catch a invalid selection. We catch out of stock, and let's go ahead and let's try this out. So basically, it says insufficient funds. Please insert an additional 2 coins. Well, what happens if we do 9? We go ahead and run that. Assuming, there we go, additional 1 coin. If we change it to 3, we can see it's able to catch all of these exceptions for us. There we go, 7 coins. But if I change it to 11 coins, success, it's going to give us chips. So this is really a pretty good example of a common use case here, where you want to handle the different situations that could occur if the optimal condition isn't met, and you're able to do it in a very object-oriented way, along with some functional programming by using the pattern matching. So we can also build another example here that they're showing. Let's go ahead and try this out. And we have a nourish function, and this one says try the vending machine, catch the error, and print I couldn't buy from that machine. Okay, let's go ahead and try this. And then let's go ahead and let's eat some related errors here. And let's go ahead and do that. And we'll run, couldn't buy that from the vending machine. And so in a nutshell, it says we're able to actually, the eat item function lists the vending machine errors, the catch, and its errors respond to the items in that list. So it looks like that's working pretty well. And so we also could try to do some other things too. If we take a look at what else you can do, for example, if you want to use a try, you could, let's say, fetch some data from a disk. If not, return a null value. You could also disable error propagation. So let try photo. I don't know if this would work. Let's go ahead and try that out. Does this work? In this case, we do have an error. Let photo try, but we need to have some kind of we're not catching anything there. But basically, in this particular example, we would load the image at a given path or throw an error if the image can't be loaded. In this case, because the image is shipped with the application, no error will be thrown runtime, so it's appropriate to disable error propagation. So that's kind of interesting. So you can actually tell it to not throw errors, because maybe that's something you don't want to show up in a production application, which actually does make sense. And there's also cleanup actions, so you can use a defer statement to clean up a current block of code. So that's pretty cool. So let's say you're going through it and you're processing a file, and you're saying if the file exists, let the file open. Otherwise, defer the close. And so after you do your work, it'll automatically close. So this is similar to Python, where you have a context where there's some action that occurs after you're doing some work. So not bad. So we're able to get the gist of handling errors in Swift. I'll definitely take a look at that further when I get a chance. And so it looks like next week I'm going to dive into concurrency. I'm actually a huge fan of concurrency. and I've used it actually in Objective-C quite a bit. There's some really cool things in the Cocoa language or Cocoa framework that we will be able to tap into. All right, so that'll be it for today. See you all next week.